and welcome to another session for the JEE Sprint 2.0. In this session, we are going to discuss surface chemistry and electrochemistry. These two topics are highly important for the physical chemistry portion and they're extremely important to grasp. Surface chemistry is slightly tricky, but electrochemistry में numericals आते हैं, numericals straightforward आते हैं. उतने difficult numericals नहीं आते. A lot of people leave electrochemistry numericals, but we should not. In the JEE Mains 2019 paper, which was conducted in January, there were about 12 questions that had come collectively from these two topics. So it is important that we master these two topics so that we can move ahead and solve other sections of chemistry very conveniently, and our marks is at a decent level. So without wasting any more time, let's start today's session with the first question, which is this. For coagulation of arsenic sulfide, which of the following salt solution will be most effective? Now, coagulation is a process in which ions are being brought closer. Coagulation is a function of attraction. Now, arsenic sulfide is As2S3, and if you remember, As2S3 plus H2S will generate a negatively charged sol. Negatively charged sol. How do we know that it will generate a negatively charged sol? There is something known as the preferential adsorption theory, which suggests that the common ion is adsorbed. Now, if you take arsenic sulfide and H2S, arsenic sulfide sol will be H2S as As2S3. What is the common ion? Sulfide. So arsenic sulfide का एक molecule के ऊपर sulfide present होगा. Okay, it will be present on the top of it, like this is arsenic sulfide. On the top of it, there will be S2 minus units which will be present, which will impart an overall negative charge to the sol particles. Now, if we are supposed to coagulate, so if this and another such particle has to come closer, then what should we have to induce the interactive interaction? Negative and negative to attract karega nahi. So what should we have is a positively charged species. Higher the charge of the species, higher the charge on the species, the tendency for coagulation will be higher. So सबसे ज़्यादा positive charge किस cation पे है? Al3 plus, Na plus, Ba2 plus, and you have Na plus ion. So the right answer will be A. Right answer will be A. So coagulating power is maximum with AlCl3. Always remember there are two terms, coagulating power and coagulation value. Coagulating power is the tendency, while coagulation value is the amount required. So अगर power ज़्यादा है तो amount कम required होगा. Okay, so if coagulating power is more, then the amount of that required to coagulate something will be less. So power and they are inversely related to each other. Let's move on to the next question. The next question is from electrochemistry. The question is very simple. If the stranded electrode potential for a cell is 2 volt at 300 Kelvin, then the equilibrium constant for the reaction is at 300 Kelvin is approximately. Now, very important point to note over here is the value of temperature given is 300 Kelvin, and we generally use a very simple relation known as Nernst equation. So E equals to E naught minus RT by NF ln K. आप एक relation use करते हैं. In this relation, when we change this natural log to log base 10 and we multiply this with 2.303 RT by F, when we incorporate the value of temperature as 27 degrees Celsius, the value of the whole term, this whole term 2.303 RT by F turns out to be 0.0591. In this case, we would not be using 0.0591 because the temperature is given as 300 Kelvin. So what we should do is we will solve the question from scratch and see what will be the answer to the question. So for this reaction, the equilibrium constant will be written as equal to zinc 2 plus by Cu2 plus. Okay, now the concentrations are not asked, so we can leave it as like this. We can write E equals to E naught minus RT by NF ln K. Since the reaction is at equilibrium, remember that at equilibrium delta G is 0, so E cell will be 0. This part will also be equal to 0, but E naught is not equal to 0. So if E is equal to 0, I will write this thing as 0 E naught minus R value is to be taken as 8 times 300 by N value, which is 2, because 2 electrons are exchanged, 96500 ln K. Also it is given that it is 2 volts, so I'll bring it over here and this will become 2 volts. Minus and minus will get cancelled out. 8 times 300 by 2, 96. We are supposed to take it as 96000 ln K. This is 4 and 16 to 32 by 3, that will be equal to almost 150, slightly more than 150. So the answer should be equal to about 160, which is equal to ln K, or K will be equal to e to the power 160. Okay, the right answer for this question will be A. The right answer to this question is A. Not a very difficult question. It will take about 2 minutes to solve the question, but you can very easily get 4 marks in this. Let's move ahead. The anodic half cell of lead acid battery is recharged using electricity of 0.05 Faraday. The amount of PbSO4 electrolyzed in grams during the process. Now, if you do not remember what is a lead acid battery, you do not have to worry about this. ठीक है? Now, एक बात बताओ, अगर lead acid battery में अगर reaction हो रहा है, then what at the most will happen? If you are given the amount of PbSO4, then obviously something is getting Pb2 plus is probably changing into Pb by taking 2 electrons. This is up isko recharge. Now the point is, if it is 2 electrons which is involved, that is our point of concern. That is our point. That is the information that we will carry forward. Even if we do not know the reaction, that makes no difference. Lead sulfate है, Pb2 plus के ऊपर 2 यूनिट पॉजिटिव चार्ज है, वो lead में ही कन्वर्ट करेगा. Okay, so ये 2 electrons हमको involve हो गए. So n is equal to 2. What does this suggest? That if I take n is equal to, so for one ion I require 2 electrons. So 1 mole of ions will require 2 moles of electrons. Or what we can write is that for 1 mole of PbSO4, 2 Faraday of charge is required. 2 Faraday of charge is required for 1 mole, because for 2 unit of electrons is required. So for 1 mole, 2 Faraday of charge are 2 moles of electrons. मतलब 2 Faraday charge, 1 mole of electron has 1 Faraday charge. 1 mole के लिए 2 Faraday charge लगेगा. Now, electricity of 0.05 Faraday. So 2 Faraday is for 1 mole. 1 Faraday will be equal for 1 by 2 of a mole. And 0.05 Faraday will be for 1 by 2 times 0.05 moles. Which if I want to convert into grams, I'll multiply this with 303. I'll multiply this with 303. What will be the answer? So this will be 15. Like if I divide this will be 15, 1.5 and 15, 5, 75. The answer कुछ 7.6 होना चाहिए. The answer will be 7.6. The answer will be 7.6 grams. Straightforward question, very simple way to solve the question. Let's move on to the next one. Next, hemoglobin and gold sol are examples of. Hemoglobin is an example of a positively charged sol and gold sol, a metal sols are generally negatively charged. So the right answer to this question is positively charged and negatively charged sols respectively. The right answer is D. Please do remember ये sols कौन-कौन से तरह के होते हैं, इसको याद रख लीजिए. Okay? Let's move on to the next question. Okay, so let's see how do we solve this question. In the cell, platinum hydrogen, which is at 1 bar HCl Ag. So in a solution of in an electrochemical cell, there is a silver electrode and there is HCl solution and there is a gas electrode like hydrogen. The cell potential is 0.92 when 10 raised to minus 6 molar HCl solution is used. The standard electrode potential of AgCl electrode. How do we solve the question? First we need to know that what reaction is occurring. So reaction हम क्या लिखेंगे? So hydrogen is converting into H plus. Okay, I can write this. Hydrogen is converting into H plus, 2H plus लिख देते हैं और यहाँ पे 2 electrons निकाल दिया हमने. Similarly, AgCl हमको इस electrode के लिए निकालना है. I have to identify it for this electrode. Forget about this part. I have to identify it for this electrode. So how do we write this equation? Ag will take up an electron, will change into Ag plus Cl minus. Why do we write this? Ag plus will take up an electron. So if I balance this reaction, what will the reaction turn out to be? H2 plus AgCl plus, I take 2 electrons, ये electrons cancel हो जाएंगे and I will get 2H plus 2Ag plus 2Cl minus, something like this. I'll get something like this. Okay, I'll get this. Now, so the K equilibrium constant for this will be written as products by reactants. Now reactants, AgCl is solid, silver is solid and hydrogen आपने 1 bar pressure पे लिया है. So K का effectively हमारा expression क्या आ जाए? H plus square Cl minus square. ये हो जाना चाहिए. H plus square Cl minus square. What is the H plus ion concentration that we have taken? 10 raised to minus 6. अब इतना ही Cl minus भी present रहेगा medium में. इतना Cl minus अगर medium में present है, then what will be the equilibrium constant? 10 raised to minus 6 square, 10 raised to minus 6 square, that gives us 10 raised to minus 24. So we carry this value forward to solve the question. So how do we solve the question? We will write E cell as equal to E naught oxidation plus E naught reduction minus 0.0591 by N times log equilibrium constant. ठीक है? E cell का वैल्यू कितना दिया गया है? 0.92. E नॉट ऑक्सीडेशन, हाइड्रोजन इलेक्ट्रोड का ऑक्सीडेशन पोटेंशियल कितना होता है? 0. ये तो आर्बिट्री हम लोग को मालूम है कि इसको 0 ले लेते हैं और हमें निकालना क्या है? तो दिस इज इक्वल टू 0, दिस इज इक्वल टू लेट्स से वैल्यू x, दिस विल बी 0.0591 बाई, सो इसको बोल दिया गया कि 0.06 लेने के लिए, सो आई विल टेक इट एज 0.06. n वैल्यू विल बी इक्वल टू 2 log 10 raised to minus 24. 10 raised to minus 24. Okay, so this will turn out to be x minus, this will be 0.6 times minus 24, this will be plus 12. 24 by 2, 12 हो जाएगा, 12 6 72. Okay, 0.72. So x plus 0.72, this will be 0.92. So x value will be 0.92 minus 0.72, 0.2 आंसर हो जाना चाहिए. The answer will be A. Okay, the answer will be A. Clear? Let's move on to the next question. The next question is this. Very interesting question. कुछ solve कर, मतलब इतना मेहनत करने का काम नहीं है इसमें. इसमें बस ऑब्जर्व करना है, आंसर निकालना है. Consider the following reduction processes. ये सारे reduction process दिए गए हैं. Reducing power. Now whenever reducing power is asked, that means the element is undergoing oxidation and trying to reduce something else. Okay? Reducing power. So element is undergoing oxidation, trying to reduce something else. So what we have to do is we have to reverse the reactions. If we reverse the reaction, that will become the oxidation reaction, and the one which has the highest value of E naught will be most favorable, because highest positive value of E naught gives the most negative delta G, because delta G is equal to minus NFE. So हम इसको उल्टा कर देते हैं, देखते हैं कि सबसे ज्यादा वैल्यू किसकी आएगी. If I reverse this, if zinc changes into zinc 2 plus, it will be 0.76, this will be 2.87, this will be 2.36, this will be 0.25. So the one which will be having which will have the maximum oxidation potential will be calcium. So reducing power for calcium will be maximum, followed by magnesium. Calcium followed by magnesium. Let's see if we have an option. Calcium followed by magnesium. The right answer should be B. Takes less than 1 minute to solve the question. Okay? Let's move on to the next question. The next question is this. Given the equilibrium constant Kc for the reaction, calculate the E naught of the cell. This is a very simple question. Equilibrium constant is given, beta. If equilibrium constant is given, then E cell will be equal to 0. So what we will do is E equals to E naught minus 0.0591 by n log Kc. Okay, this will be equal to 0. E naught needs to be calculated. 0.0591 by n. N की वैल्यू कितनी होगी? How many electrons are being exchanged? 2 electrons are being exchanged. Log 10 raised to 16. So that will give us E naught minus 0.0591 by 2 times 16, that is 8. And if I take this as 0.06, this will be 48, 8648, and that will become 0.48 के आसपास होना चाहिए. So 0.48 होगा नहीं, क्योंकि ये 0.6 है नहीं, so slightly less than 0.8. So the answer should turn out to be 0.4736 volts. The answer should be 0.4736 volts. The right answer should be B. Okay, let's move on to the next question. Among the colloids, cheese, milk, smoke, the correct combination of dispersed phase and dispersion medium is. बहुत समय confusion रहता है. If somebody tries to solve this, the right answer is, if I look at the options, so solid. The dispersed phase. Okay, dispersion medium for cheese is solid, dispersion medium for milk is liquid, dispersion medium for smoke is gas. The right answer to the question is D. Now cheese का एक और भी easy way है identify करना. If you ever had cheese, like if you hold it in your hand, some liquid will come out. So liquid turns out to be the dispersed phase in the matrix which is made up of solid. Smoke contains particulate matter which is present in our dispersion medium which is made up of gas. Okay, so the right answer is D. Please do read NCERT for this. कुछ एक general examples हैं. Gel, jelly, cloud, fog, aerosol, इन सब के बारे में dispersion medium, dispersed phase क्या है उसको याद कर लीजिए. The right answer to this question is D. Next. Again, a question which does not require a lot of solving, but is a very, very nice question because a lot of people made mistake in this one. For the cell zinc 2 plus, Mx plus M, different half cell and their standard electrode potentials are given. We have to identify that if zinc is coupled with any of these, in which case maximum voltage, maximum value of E naught is obtained per electron transferred, not maximum value of E naught, but maximum value of E naught per electron. Maximum value of E naught per electron. Now remember, A lot of people have a query that, sir, can we take this and add them directly? Yes, as long as they are combined together to form a electrochemical cell, you can add these values. You can add these values directly, even if unequal number of electrons are being seen over here, which are involved in oxidation reduction. For example, Au3 plus is changing into Au, and for this 3 electrons would be required. Zinc 2 plus is changing into zinc, 2 electrons would be required. अगर लेकिन दोनों को मिला दिया हमने, तो reaction will automatically balance the 3 electrons given out or 2 electrons taken in, or 2 electrons given out and 3 electrons taken in, to come to a common number of electrons, that is 6. So it will not make any difference. You can directly add these values. ठीक है? Now zinc turns out to be the oxidation half cell. So zinc के लिए reduction का value दिया गया है, तो इसको oxidation value क्या लिखेंगे हम? Plus 0.76. Okay. Now if I try to couple it with these electrodes, then I should have the maximum value, maximum positive value. So with which should I be coupling it? Au3 plus. Okay. Au3 plus changing into Au is given. This is the reduction part. So this is 1.4, this is 0.8, this is 0.77, this is minus 0.44, so I will not use that as the reduction half cell. हम क्या करेंगे, इन तीनों को अगर इनसे हम ऐड करें, then maximum positive value कहाँ पे मिलेगा? इस केस में I will get the value as 0.76 plus 1.40, that will be 2.16 volts मिलेगा if I combine this and this. But in this case, how many electrons are being exchanged? 2 यहाँ पे exchange हो रहा है and 3 electrons यहाँ पे. So total of, what is the LCM of these two? 6. So इसको हम 6 से divide कर देंगे. So effectively how many, what is the voltage per? So this will be 0.36 आ जा रहा है. Now if I combine 0.76 with 0.8, the answer turns out to be 1.56. But in this case 2 electrons and 1 electron, so LCM for 2 and 1 will be 2. हम इसको 2 से divide करते हैं and the answer will turn out to be 0.7 something. इससे तो ज़्यादा ही रहेगा. So if I combine 0.76 with 0.77 and I exchange 6 electrons between the two, obviously the answer will be even smaller. So the largest value of E naught per electron turns out to be when this is coupled with silver electrode. So the answer should be B. The answer should be B. Always remember, अगर आपको आइडेंटिफाई करना है कि कितने इलेक्ट्रॉन्स एक्सचेंज हो रहे हैं, तो दोनों हाफ सेल में जितने इलेक्ट्रॉन्स का रिक्वायरमेंट है उनका LCM ले लीजिए. If 2 रिक्वायर्ड हो रहे हैं, then 2 का LCM ले लोगे तो 2 ही आएगा. If 2 and 4 रिक्वायर्ड हो रहे हैं, then LCM ले लोगे तो 4 आ गया. If 2 and 3 रिक्वायर्ड हो रहे हैं, then total अपने LCM लिया तो आंसर 6 हो जाएगा. So 6 electrons will be involved over there. So that is the answer to this question. ठीक है? Next, the correct statements among 1 to 3 with respect to potassium that are abundant within the cell fluids is or are. They activate many enzymes, which is a right answer. They activate a lot of enzymes, mainly nerve transmitter में जो enzymes use होते हैं, they activate them a lot. Also, they activate those enzymes which are helpful in changing glucose into ATP. So the first option is correct. The first option is correct. The second option is also correct. They participate in the oxidation of glucose to produce ATP. They use those enzymes and they help in activating those enzymes which help in oxidation of glucose to ATP. They, along with sodium, they are responsible for transmission of nerve signals. This is very, very simple to know. जब भी आदमी dehydrated होता है, then their ability to process thought and process information decreases, for the reason that the nerves become like a little lazy. Okay, वो थोड़े टायर्ड हो जाते हैं, and then you are being asked by the doctor to drink oral rehydration solution. The oral rehydration solutions contains a lot of potassium and sodium. You are also asked to drink coconut water that contains a lot of potassium. So potassium helps in transmission of nerve signals. The right answer to the question is 1, 2 and 3. Okay, next. Next question is again from electrochemistry. Very simple question. कैसे solve करना है? Lambda naught m for molar conductivity in infinite dilution. This is known as molar conductivity in infinite dilution. For NaCl, HCl, NaA are 126.4, 425.9 and 100.5 Siemens centimeter square mole inverse. For 1 mole it is given. For if the conductivity for this solution, conductivity for HA is this, what is the degree of dissociation? How do we solve the question? Question is very simple, very simple. बहुत easy है question solve करना. Now HA is a weak electrolyte and एक Colorist dilution law है, उसका ये कहना है कि at infinite dilution all ions behave differently, or best to say all ions behave independently, and if they are behaving independent does not matter कहाँ से वो आ रहे हैं. So HA के लिए जो ions आ रहे हैं वो NaCl और HCl और Na के मिलाने से आ रहे हैं या फिर नहीं, या फिर Ha को डिसॉल्व करके आपने लिया है, makes no difference. It does not matter whether the anion A minus is obtained from NaA or HA. At infinite dilution, its molar conductivity will be the same. So how do we solve this? So the not M for HA will be not M for NaCl plus molar conductivity for HCl minus molar conductivity for NaA. Okay, this will give us a result 425.9 plus 100.5 minus 126.4. If I solve this, 9, 5, 14 and minus 4, 0, 5, 6, 400 centimeter square mole inverse. Okay, I'll get this value for at infinite dilution. This should be the value of molar conductivity. Okay, at infinite dilution this should be the value of molar conductivity. Now to calculate degree of dissociation, I need to know the molar conductivity at a given dilution, and I compare it with whatever is at infinite dilution. So at a given concentration, that is 0.01 m molar concentration of HA, this is the value. How do we identify this? That will be 1000 times, this is kappa by C, 5 into 10 raised to minus 5 by 0.001. Okay, so this will turn out to be the 10 raised to 3, 10 raised to 6, that will be 50 Siemens centimeter square mole inverse. So at a given concentration it is 50, and ideally the value at infinite dilution is 400. So what is the value of alpha? This. So 50 by 400. What is the answer? What should the answer be? Answer should be B. Answer should be B. A very simple question, straightforward. थोड़ा सा effort लगेगा लेकिन आपका आंसर निकल जाएगा. ठीक है? Let's move on to the next question. The next question is this. Again from January mains examination. Among the following, the false statement is latex is a colloidal solution of rubber particles which are positively charged. Latex is a positively charged sol or not? ये अगर आपको मालूम है, then you can solve this question very easily. Let's try to eliminate other options and then we'll come back. Tyndall effect effect can be used to distinguish between colloidal solution and truth solution. Very correct. This is the correct statement, because Tyndall effect is shown only by colloidal solution. Tyndall effect is dispersion of light particles. Dispersion of light due to the colloidal solution particles. It is possible to cause artificial rain by throwing electrified sand carrying charge opposite to one clouds. Obviously this is known as cloud seeding. Mumbai में अगर कोई रहते हैं तो वहाँ पे cloud seeding किया जाता है. Okay, so in a lot of places cloud seeding has been done so as to coagulate and cause coagulation, and coagulation के कारण वहाँ पे precipitation हो जाएगा. Lyophilic salt can be coagulated by adding electrolyte. This is very correct. You have to add an electrolyte to precipitate lyophobic. So this is the incorrect statement, because all three are correct. ये eliminations हमने निकाल दी, but it is to be known that latex is a colloidal solution which contains rubber particles which are negatively charged, not positively charged. Negatively charged solvent. Okay. The false statement is this. The right answer to the question will be A. Okay. Next, there is a question from adsorption, and it takes into consideration the critical temperature. Now, critical temperature measures the temperature, the maximum possible temperature beyond which you cannot perform liquefaction. Liquefy करने के लिए आपके दो गैस मॉलिक्यूल्स के बीच में अट्रैक्शन होना चाहिए. Okay, अगर it's just like two people who are in constant conversation with each other, आपने वो लोग दो डिफरेंट सिटी में चले गए तो शायद फोन से बात करते, बट दो डिफरेंट कंट्री में चले गए, देन इट इज पॉसिबल दैट दे माइट नॉट एंड अप इंटरेक्टिंग विद ईच अदर. ओके, सो द पॉइंट इज critical temperature measures the maximum temperature till which the attractive interaction can be felt. Maximum temperature till which attractive interaction can be felt. So जहां पे attraction की amount ज्यादा होगी वो ज्यादा critical temperature शो करेगा. Okay, so that means higher temperature तक भी उनके बीच में attraction है. So critical temperature is 33, critical temperature 190, 304, 630. So more critical temperature, so critical temperature if increases, the van der Waals gas constant A, which measures the force of attraction, also increases. And जितना ज़्यादा attraction होगा, extent of adsorption also increases. Okay, so on the basis of the data given above, predict which of the following gases shows least adsorption on a definite amount of charcoal. Least adsorption will be for hydrogen. Okay, least adsorption will be for hydrogen. Okay, so please do remember this. With this we move on to the next question. The next question is this. Which of the following statement is or are correct about the electrolysis of aqueous NaCl? This is a slightly advanced question, but I will help you understand this. In the process of electrolysis, always there are some competing ions to get deposited or to get discharged at the respective electrodes. Anode पे oxidation होगा and cathode पे reduction. So of these ions that you can see over here, like cations will travel towards the cations will travel, or oxidation will take place at anode, and cathode पे reduction होगा. Na plus will want to go to cathode, so at cathode Na plus will compete with H plus. At anode H2O will compete with Cl minus. इन दोनों competition होगा. Now the one which, how do we decide which will win? Obviously the one for which delta G value is more negative will win. But यहाँ पे तो सारे values negative में दिए हैं, तो the one in which it is least positive will win. So I take this. Okay, I take this. H2O changing into H2. This is competing with this. इसके लिए जो delta G का value होगा वो positive plus 0.27 times NF के form में रहेगा. This will be because delta G is equal to minus NFE. So what I'll do is I'll place this over here and this will be NF times 2.71. This will be 0.83 times NF. So less positive value is this. So hydrogen will get liberated. So during the electrolysis of NaCl, chlorine is liberated at the anode. Let's see. ये -1.23 है, -1.36 है. किसका लिबरेशन होना चाहिए? ऑक्सीजन का लिबरेशन होना चाहिए. देखिए H2O चेंजिंग इनटू ऑक्सीजन, बट ऑक्सीजन का लिबरेशन होता नहीं है बिकॉज देयर इज समथिंग नोन एज ओवर पोटेंशियल. ओवर पोटेंशियल इज द एक्सेस अमाउंट ऑफ पोटेंशियल दैट यू नीड टू provide so as to make the reaction feasible. Delta G only tells us that whether the process is thermodynamically feasible or not. जैसे कि एक आयरन के सैंपल का रस्टिंग, it is thermodynamically feasible but kinetically it's not feasible. Kinetically feasible means it is not a fast reaction. So this reaction is very slow. So by the time this reaction takes place, this reaction gets almost over. So over potential इसका ज़्यादा है और इसके कारण क्लोरीन का लिबरेशन होता है. So chlorine gets liberated at the anode, which is the right statement of this question. Which is the right statement in this question. After the electrolysis of NaCl, the solution turns alkaline. After the electrolysis of NaCl, the solution turns alkaline. How do we know that? How do we know that? This hydrogen gets liberated, Na is formed over here, and Na will react. Na will be if hydrogen is getting liberated, then we can write H2O. If it's changing into H2, H2O changing into H2, 2OH minus is 2 electron. This will be the balanced reaction. Okay, so OH minus is being produced because hydrogen is liberated, the solution will turn alkaline. This is also a right statement. During the electrolysis of very dilute solution of NaCl, the chlorine gas is liberated at anode. Dilute solution of NaCl, chlorine is liberated at anode is not the right answer because is not a right statement because in a dilute solution of NaCl, the amount of sodium and chlorine present is very small, and so over potential is not brought into picture. NaCl, chlorine will not get liberated. Again, in this case, rather than chlorine, oxygen will get liberated. Okay. Next, during the electrolysis of NaCl using Hg electrode, sodium amalgam is formed at the cathode, which is correct. The cathode is known as the reactive cathode, and reactive cathodes are the one which can react with those species which are obtained in the course of reaction. So sodium can react with cathode, and that can pull that not so favorable reaction towards favorability, and that's the reason this statement turns out to be correct. So correct statement हमें बताना है तो क्या हो जाएगा? A, C and D. A, C and D will be the right statement in this question. This is the last question for today. Which of the following is incorrect? Critical micelle concentration decreases with increase. Critical micelle concentration decrease with size of hydrocarbon part of soap or detergent. Yeah. To form a micelle, I require a hydrophobic part. Okay. Now, if the size of hydrophobic part increases, the amount of that substance required is less. Okay. So, if the size of hydrocarbon part is more, critical micelle concentration, the amount of substance required to form micelle will be less. So this statement is correct. Is smaller the value of gold number, larger is its protecting power. Gold number measures the protecting power of a lyophobic colloid by a lyophilic colloid. तो lyophilic colloid क्या करता है? उसको सराउंड कर लेता है. ओके, उसको सराउंड करके उसको बोलता है कि भाई तुमको मैं प्रेसिपिटेट होने नहीं दूंगा. Now, the one which has higher gold number means they are required in a larger amount, and if they are required in a larger amount, their protection power is less. So smaller the value of gold number, larger is its protection power, which is also a correct statement. For a negatively charged salt, the coagulation value varies as this. Coagulation value, so let's evaluate the third statement. For a negatively charged salt, the coagulation value varies as this. So coagulation power is proportional to the charge on ion. जितना ज्यादा चार्ज रहेगा कोएगुलेट करने की ability उतनी ज़्यादा रहेगी, tendency will be higher, and it is inversely proportional to coagulation value. So coagulation power will be highest for this, so coagulation value will be least for Al3 plus. Okay, so this statement is incorrect. Let's evaluate the last statement. For a positively charged salt, the coagulation power varies as PO4 3 minus SO4. Obviously, charge increases, ability to coagulate also increases. So this is the right statement. The right answer to the question is C. Okay, the right answer to the question is C. So with this, we end today's session, and in this session, I hope you have learned a few things about how to solve questions quickly and how to solve questions without any fear, remembering how to evaluate coagulating power, coagulation value, what are micelles. And if you have liked the video, please do like, share and subscribe, and please do join me in the next session of mine, which is gonna be on equilibrium, in which we will primarily be taking some questions from ionic equilibrium. So I hope you have learned a few things from here, and will apply and solve as many questions as possible. So this is Saurav Goswami signing off, and I wish you all the very best. Thank you. Thanks a lot, guys. Bye bye.